I'm moving back and forth here. I'm still getting like. Okay. So, quick show of hands. For those of you who actually use web browsers instead of just command line interfaces, how many of you actually check to see if the site you're going to is running underneath HTTPS and you've got the little lock icon in your browser showing you that you're all nice and secure? Let's just show of hands of who actually checks and makes sure. Okay, now show of hands, who actually checks to make sure that the DNS information that you have been presented when you do a lookup has not been tampered with? There's always one. So ideally we want to get the rest of you to the point where you feel confident that the information that is coming down to you hasn't been tampered with. Several other systems on the that are commonly used on the internet have already made these steps. HTTP is transitioned over HTTPS. We're seeing a lot of sites that are not just financial that are starting to use HTTPS. Long ago, we got rid of using Telnet to connect from machine to machine, and probably some of the younger people in the audience are probably looking at me funny and wondering what Telnet actually is. It was replaced with SSH. So we've made this progress in getting safer, in quotes, but one of our core foundations has still been left unprotected. And it's going to take a couple of steps. We're in some interesting chicken and egg problems that as these services have been transitioned, it's harder and harder the more widespread that service is. And DNS is pretty widespread. So we're going to have to make some interesting steps. So DNSSEC is our solution, but what is it really? There's 4 elements and areas that kind of play into this. We've got the individual records themselves signed. We've got some element that will go ahead and later verify that they're signed. But just having a signature there isn't enough. We need to know that there's a chain of trust starting at some anchor point. And in dealing with all this, we're adding new record types to DNS itself. So on authoritative servers, some changes need to take place. We need to make some changes mentally compared to how we originally used to think about deploying DNS servers, including in the ways the server is set up, how we're dealing with the keying information, updating information on the server, and what might be new in some DNS setups, some routine actions that were not actually performed in the past. But before making any of these changes yourself, you need to sit down and make sure we've got some baselines going on. This presentation is kind of going to assume that you've already got a working DNS setup, or you know how to create a working DNS setup, and that your name server software is compatible with the new DNSSEC records, and really importantly, your secondaries software is compatible. If you've done an install within the past couple of years, you've got a recent version of a name server. However, your secondary software is not always compatible. We started seeing issues with DNS servers that were acting only as secondaries, some of these large farm servers, running into problems when they started turning up the new IPsec, the IPsec records, such as the Quad A. The problem with those servers were when they did a zone transfer, they assumed that there's going to be these set record types, and they're going to store them in their custom created database that knows about every record type that should be in DNS. Well, they were handed a record type that wasn't, and a lot of them had a whole bunch of issues. Some simply just failed the zone transfer and wouldn't actually serve it up. There were a couple that actually crashed. So we've got this keying, and we need to determine like which castle or which part of the castle we're going to protect. First off, probably the one that you would want to protect the most is the stuff that you're sending out and sending external. A lot of people's external DNS zones don't change all that often. You set it up with www, maybe some MX records, and you're pretty much set. It flies on autopilot for a good length of time. Those are good candidates to sign, lightweight on your infrastructure, easy to set up, get going. The zones that you probably don't want to sign, even in a corporate environment, are zones that are populated by dynamic DNS, where the client is pushing DNS information up to the server. Because where's that information actually coming from? You've got some box on your network that has an IP address, is connecting to your DDNS server and says, "Hi, I'm Bob." And the DDNS server goes, "Okay, I'll mark down, guy named Bob is at this IP address." There's no trust there. Anybody who have gotten onto your network can start advertising names. So that's not something you really want to put assurances on. So it's not worthwhile to really worry about signing zones that have heavy DDNS updates. The other consideration is within the DNSSEC world, we start to treat the serial number in the SOA record actually as a serial number that monotonically increases generally by 1, rather than the date that the last person who edited the zone file has put in there. That using the date was sort of a hack back in the day to kind of give people an idea of when things changed. Not bad information to have, but it makes managing the zone files more difficult, and as I'll discuss later, we actually get some data information back just through the process itself. So when we're serving public DNS, we've tended to set up a machine, kept it relatively stripped down, installed the serving software on it, and dropped it in a DMZ somewhere. It's got some protections, and it definitely doesn't have any access back inside. This works well when really the worst case scenario, aside from it being used as a launch-off point, is you kind of wipe the machine and start over again. There's not much damage you can do to a DNS server that just can't be solved by a reinstall and pushing that zone file back out on there. Except now that we've got keying information. So the risk is much higher. Your server getting compromised means that this keying information can get out, and that's a much bigger headache than just a reinstall. One thing to think about real quickly in doing that is like, okay, well, I just won't have the keys on the server. I will do all the signing on an internal machine and copy the signed zone files onto the DNS server itself, and everything will be fine and happy. Perfectly legitimate solution. This is actually what I use at home because I change my zone information once every 6-8 months. It's not a very high overhead to go ahead, make the change, run the couple of commands it takes to push the new zone file into place. Now, if you've got more changes more often, you're in a corporate environment, then that method of offline signing is probably not going to work for you. You're going to need something that's more online. And we've got basically two mechanisms to deal with this. You can set the server up as a client reachable host, and that DNS master will have the keys on it. It can handle the updates, do the signing, and publish its own zone file. This runs into that problem I talked about a little bit earlier, where the keys are right there on the machine. Now, if it's internal to your company and you're signing in inside zone, this may not be as big of an issue for you. If it's sitting out on the internet-facing side, it's a little bit more of an issue. You can take it a step further by instead of having a DNS master sitting out on the in your DMZ, you can have a DNS slave or secondary sitting out there, at which point you have the real master tucked behind like an application firewall that will additionally filter out DNS protocol information and only allow notifies and zone transfers, thereby reducing the attack surface of that interior box. Okay, now we're going to get into a little bit of the nuts and bolts now that we've got everything else set up. We need to set up some keys to actually do the signing. These are using public key style cryptography. However, we don't have any expiration dates on these keys. That makes everything a lot more complex. We've got other mechanisms that how we'll handle that. Rather than trying to have revocations and keys keys with hard expiration dates, we're just going to rotate our keys on a regular basis since the entire verification is all done online anyway. So a zone signing key, basically it has a lifetime. Generally it's recommended of about 3 months. Some places rotate even faster than that. And we don't need a very heavy weight key with this. The first line there is sort of the general form that the command takes, and right below it I actually have a line with a concrete example. And if you notice, it's only a 1024-bit key for the protection. Now, we could increase this as much as we want. The problem being is we're doing relatively little work initially to sign this zone. Clients out there have to verify this every time they want to look up that zone. So if you have an absolutely huge key, you're going to put a lot of burden on small little devices that tend not to have a lot of CPU power that may be trying to do the DNSSEC verification. So while normally the cryptography advocates are saying, hey, use as much as you can, just throw a beefier machine at it, the problem is that your percentage of the work is relatively low considering how many devices are actually going to be doing verifications instead. The advantage, however, is even with the low bit rate, you're throwing this away in 3 months. That if someone is working to attack that key, 3 months later, they've got to start over because you've switched off to a new key, and the way the chaining infrastructure works, they can no longer make any use of the old key because it's more of an online stepping through the chain every single time verification that if the parent is not pointing to the correct key, the verification chain just doesn't happen. So having an old key doesn't get anybody anything. Now, signing that zone signing key is the key signing key. This we hang on to a little bit longer, rotated about every year. And the reason why we hold on to this one longer is this is what our parent knows about. So there's a couple mechanisms of establishing the chain, which I'll go into shortly. But this generally involves communication and synchronization with another zone to set up this information. So it's a little bit more involved of a task. So you don't want to do it quite as often because there's a little bit of additional risk. There's much more overhead in making that change. In my concrete example, you'll notice I've got it set to 4096. Actually, ISC's examples actually have it only at 2048. So there's some wiggle room there. So after we've actually generated the keys themselves, we need to actually include it into the zone file. These examples are for bind that we can actually use an include directive, or just go ahead and dump the resulting outputs from the keygen commands to the end of our zone file, and the tools just work. So signing the zone is actually really, really simple if you're using bind 9. You've got one command line that actually looks much more complex than it actually is. That we've got, basically we're just taking the zone, feeding it the keys, and saying, hey, go ahead and do your work. One thing that we are doing additionally here is we're specifying our random source. Pulling off of dev random, depending on your system and how loaded it is and how much entropy in that pool, that may go really quick, or you may be sitting there for days just because it's not generating a large enough entropy pool. You may have to look at other entropy sources or use dev urandom instead. The other interesting thing to note is the -L option, which right now we're pointing dlv.isc.org at. That's for domain look-aside verification, which I'll be getting to shortly. It's basically telling the sign zone command to output another file that makes it easy to hook up with the DLV. This is just a basic run through on the sign zone command. There's a bunch more command line options. You can actually tell it to automatically increment the serial number each time through, such that when people are editing the zone file, they know, okay, we make the tactical changes that we're going to make, and then we run this command, which resigns it and increments the serial number. So that serial number in the SOA can be incremented as part of the automated procedure, eliminating one of the failings and problems people run into when trying to roll out changes within DNS, that they forget to update the serial and then wonder why none of their changes are propagating. Additionally, you can do some fine-tuning of the dates as far as when the records actually are thought to have been signed, and that way, no matter for periodic changes, you can basically say when you want that zone file to appear to be active. That gives you a little bit better administrative control as far as like rolling it out, that the signing can actually happen hours ahead of time and then still push at the appropriate time. So there's other command line options that I'm not going to go into that give you these sort of additional controls and flexibility. But as far as just getting it running, that's all the command that you need. As far as managing entire domain zones, as you start to get into the larger corporate environments, there are a bunch of automation tools that are out there that basically get you much better click and go on the signing and so forth. I'm not presenting any of those. You should understand what's kind of going on behind the scenes a little bit before trying to automate, and everybody's environment is going to be a little bit different, so which tool you pick is up to your environment. So now that we've got the signed zone file, we need to actually get it out into a server. But before we do that, we want to make a couple small changes to the named.conf for the zone. And we're just enabling since this is an authoritative server, we're just setting it up DNSSEC enabled, yes. I've gone ahead and turned off recursion and restricting the zone transfers to just the peers group, which I've listed all of my secondary servers in. This is basically reducing some of the attack surface of the DNS server, that if you've got something sitting in a DMZ or internet facing, that you're the authoritative for your zone. There's no reason that you need to be providing recursive DNS service to everybody on the internet. So as an authoritative, it's not needed. Just go ahead and turn that off. Similar with the allow zone transfers, some people make the argument that they want to turn down zone transfers to everyone so that people don't see what hosts they've got in their zone. In my personal opinion, that's security through obscurity. That instead I disallow zone transfers to anybody but my peers to reduce the attack surface. That if an individual client attempts to run that part of the protocol and gets rejected by this, that's one less area of code that can have a bug that will be exploited. If a zone transfer code path has an exploit, I'm more limited, more likely limited to just one of my secondaries attacking me instead of the entire internet. So now that I've done that, I'm going to go ahead and copy my signed zone file into place. I'm not going to worry about deleting the old one. The DNSSEC signing command actually emits the zone file with a .signed extension to differentiate it from everything else. I am just inside my named.conf going to change the name of the file internally so anybody looking at the config file knows that, hey, there's something a little bit different about this zone. And at that point, restart, reload, bind, either restarting the daemon or using the commands to tell it internally to reset and reload. So now we've got a daemon out there who is serving up a zone with these additional records. Because all DNSSEC is, like I said earlier, is a bunch of additional records that are associated with the zone. We can check to see that everything went happy with the daemon on startup. We can go ahead and look at the logs. And if you notice that worst.com, it went ahead and loaded that serial. And there's an indication that it realized that it was a signed domain, a signed zone, sorry. The line above it on Ascendi.com clearly doesn't have the sign on the end. It wasn't a signed zone. The server recognizes it. Then we'll go ahead and check the information that the server is handing out itself. Just run dig, the local server, and pull up the SOA record of the domain. And you can see that after the SOA line, sorry about sort of the line breaks. For me to try to get it all on one line, you wouldn't be able to read it. So you can see that there in the answer section, there's an SOA record, and there's also this RRSIG record. And that's basically the signature on the SOA. So we can see that the server itself is handing out this information when it's asked, and the server itself appears to be in good shape at this point. So we're done, right? Almost. I mentioned earlier that there's this chain that needs to be followed. We've got a link, but we've got this isolated single link. It's a little loop of metal, and it's about as useful as any other little loop of metal, usually as a napkin ring. In order for it to actually be of use, we need to hook it into the chain. So there's basically two ways at this point of hooking it into the trust chain. We can use a DS record and chain from our immediate parent. In the case of my domain, horse.com, I would basically get this DS record in com, and assuming that com is fully signed, which then assumes dot is fully signed, it should all just work. Unfortunately, dot isn't signed, and com isn't quite signed yet. So that's not going to immediately work for us. But if I had a subdomain of worst that was signed, what I would be doing is putting the DS record in worst, such that foo.worst.com's, that subdomain and all the records underneath that had that chain. This is really the way it should work, because it is using the existing trust relationships that already are natively in DNS, that the parent zone already has an NS record pointing down to you for your portion of the zone, and you've got some relationship existing there. They would just, instead of having just a NS record, they'd have the NS record and the DS record. Pretty straightforward. You're leveraging off of what's already there, except that we're not there yet. So we've got to implement a kludge. Domain look-aside verification. So rather than just assuming that our trust anchor goes straight up the path, we're going to delegate out that chain off to an entirely different domain. In this case, we're using ISC's DLV, and what we're going to end up doing is we're going to have ISC, as part of their DLV zone, have a record that says, oh yeah, I know about worst.com. Here is a reference to his keying information, and we've signed it at our level, saying that it's golden, thereby establishing that chain. The DNSSEC sign zone command earlier, I mentioned there was that -L option to generate that DLV set. We're going to take that and we're going to submit that to our DLV vendor. Now, that DLV vendor doesn't know who we are. Our parent does, but this DLV vendor just knows that we're just some random email address sitting out on the net somewhere who has attempted to email them some file, or we've gone in through ISC's web interface and it knows that, okay, the account works because it was able to send email back to that account, but it really doesn't have any way to associate your email address with the fact that you've got control over that domain. So what ISC has been doing is they've asked one to insert a record of their choosing into your domain. That when I sent email off to ISC saying, hey, here's my DLV set, I want to be part of the family, they sent me back an email bright and early the next morning, actually before 8 a.m., that, okay, that's nice. We need you to show that you are who you think you say you are, and go ahead and add the following record with this random nonce into your name server, into that zone file, have it publish so we can verify that you have control over the domain. So I went ahead, added that record in, sent the email back saying, okay, it's there, it's live. At which point they turned around, they verified it, and they added worst.com into their DLV setup. This was done around 10 a.m. that same morning. The start to finish time would have been a lot sooner had I not sent the initial submission at 1 a.m., but closer to the start of their business hours. But from their first email to me saying, hey, we've received your request, to it working was about 2 hours. This is actually a bit faster now that they've got a web interface to handle the whole thing, and there's less humans in the loop. You can hit that site at https://dlvisc.org. So one of the things that I mentioned is that there's periodic actions that you're going to need to take even as an authoritative server that we all know about. Yeah, you need to periodically make changes to your zone file itself, but one of the other things that you need to pay attention to is key rotations and general signing. DNSSEC requires that you pay much more attention to what's going on with your DNS setup than before. Previously, it was fire and forget, and you just kind of sit back, and when mail stops flowing in, that's one of the things you check. In the past, I have gone greater than 2 years without looking at my DNS server. DNSSEC requires that I poke it once a month because your signing has a 30-day lifetime. You've got some slop at the start and the back, but the infrastructure knows when that zone was signed, and validation starts ignoring things after 30 days from when it was signed. So that's why you've got to re-sign periodically. And additionally, that fits in with the key rotation. So basically, once a month, you're going to poke at it. And that's with making no changes to the zone file itself. Now, if you make changes to the zone file and re-sign, that actually does reset that 30-day clock. But you still want to make sure that on your 3-month boundaries, you regenerate your zone signing key. The keys themselves have actually no built-in expiration. It relies on that trust chain being verified at lookup. So the rotations and regeneration of your keying material is important from that regard. So we're going to take a step over to the other side and talk a little bit about your caching and your recursive resolvers. This is almost prime time. Really, the strong use I feel at this point is periodically checking the logs and seeing what percentage of your domains that you've been looking up actually have DNSSEC enabled. Because there's a bit of a chicken and egg problem with the whole thing, that people aren't building and pushing out DNSSEC authoritative. Why bother? Nobody's checking. Nobody's bothering to checking because, hey, nobody's actually pushing out DNSSEC. So this is of a less importance than getting an authoritative setup, in my opinion. That if every one of you went out and pushed for your domain and your company's domain to set up DNSSEC on the authoritative, and none of you did anything in the caching recursive, I'd be fine with that. Because it's getting that first step and getting the authoritative out there first. That said, the recursive setup is actually relatively simple. We're going to make some changes in named.conf for the DLV. We need to add a trusted keys field for the top of our trust anchor for the DLV. So in this case, I'm adding dlv.isc.org. And you can actually have multiple trust anchors. So it's not just the one. And there is this trusted keys, some additional algorithm bits there, and what would be a very, very large block of encoded data, which I have abbreviated down to just a few characters. Differing than the authoritative, we've got not just DNSSEC enabled, yes, but we've got telling it, hey, go ahead and do the validation, and we've pointed and said, hey, the DNS look aside, here's our trust anchor. Aside from having trust anchors off to the side, it's possible to pull in trust anchors for TLDs that are already part of the game. This is necessary until we actually get dot signed, at which point both of these schemes largely go away. You rely on dot being signed and having a nice clean trust anchor all the way from the top. This is sort of a hack around it. You can pull down a list of trust anchors for top-level domains, like BR, from there on down. And currently it's distributed as XML, but there are instructions at HTTPS ITAR IANA org instructions for converting it into a mechanism that bind can just include rather than actually having to suck it into your named.conf. You can have it sitting on its independent file, and that makes it much easier to update when these things change, when they do key rotations, when new people join into the party. So for your recursive, there's a couple of things that you need to do on a regular basis. You need to keep your trust anchors updated. You've got the DLV that needs to be kept updated. You've got the ITAR that needs to be updated. Most of these things are announced ahead of time that, hey, things are changing via mailing lists. There are mechanisms for doing automated updates if you're comfortable with letting these things run in the background without you hand-holding it entirely and watching it with an eagle eye. A lot of more background information on this can be found in RFC 5011. The other thing you may want to do if you're actually running a recursive server is check the stats in the log files to see what's getting verified, what's not being verified, what thinks it's running DNSSEC but is not properly set up. That's kind of interesting information to look at, just to get a feel for what's going on in the world and what you're relying on and what you think you're relying on for your own network access. So we're going to take a peek underneath the hood and look at some more of the details of the individual resource records. Just so you've got a feel for what's going on if you actually see them and you go, hey, I know that. That's DNSSEC. So DNS key. This record is for both your zone signing key and your key signing key. You've got the top level TTL IN DNS key. You've got a flags field, which will be of one of three values, 257, 256, or 0. The 257 versus 256 indicates whether it's a key signing key or a zone signing key. Any other value is invalid. 0 basically means that your validation mechanisms ignore that is something else for some other purpose. Yeah, it's there, just don't really touch it. Again, I've abbreviated the huge block of encoding that would normally be there. RRSIG. This is sort of the crux of DNSSEC, that for any resource record that is in the zone file, there's an accompanying RRSIG record that is the signature for that record. This is what gets handed out at the same time as the requested record, and it allows people to actually do the verification. There's some interesting information in here, including pointing out start and end times and the parent of the record that you're looking up. This next one is kind of interesting. The NSEC record. This is used to authoritatively say that something is not within DNSSEC underneath an otherwise signed zone. It's basically proving non-existence. Again, with an example, let's say I looked up google.com through this DLV. So within DIG, the question section says, hey, I'm looking up google.com, DLV, isec.org. I definitely want that NSEC record for the domain. And basically, there's no answer section that's going to come back in the response. But in the authority section, we're going to see this fairly interesting record. We see a really what appears to be a random domain, germanfamily.com.dlv.isc.org, and we see that it's an NSEC record, and then with the data load of greenpeas.com.dlv.isc.org. And then additional record types that are available for it. The interesting thing to note on this, and the key takeaway, is that Google.com lexically sorts in between GermanFamily.com and Greenpeas.com. What this record is saying is that particular zone has authoritative in a record for that first domain. It's got an authoritative for that second domain, and there is nothing else in between. Basically saying, hey, there's a gap here. If I knew about it, I'd tell you, but I'm proving to you with this signed record, there's a gap. Sure, do you? Excellent question. The question was, does that give some capability of an attacker of knowing what's in the zone? Yes, it does. In a second, I'll be talking about a solution to that, and personally, I actually don't care. As I said earlier, if you're worried about whether or not an attacker can enumerate your domain or not, and you're relying on that for security, you've got a world of other problems that you probably should be paying attention to. Merely knowing the contents of a zone, I don't believe is a significant risk. But that said, I will be talking about something shortly that covers that. Also, the previous three records are covered in RFC 4034. The fourth one covered in that RFC is the DS record. This is something that would be installed into the parent zone. In this case, it would be COM. And these are records that are stating what the key is, the KSK, for my zone. Now, when I said earlier that there needs to be some hand-holding and some adjustments on the year mark, if I change the KSK, I got to tell my parent to change this record. So this is why you don't want the KSK to change all that often. You rely on the zone signing key to change on a regular basis for the individual record security, because you really don't want to be trying to juggle that game on a regular basis, especially if your parent is handling it manually, because you can end up with windows that things aren't going to validate correctly. And if something goes wrong with the update process, things do not validate correctly. Recently, ISC had a little bit of a mishap with their trust anchor, and they went to go ahead and rotate it, and the script failed. And they got the lovely privilege of sending out an email to everybody on DLV Announce saying, oops, we screwed up. You probably noticed a whole bunch of failures around this time. A mistake like that, will cause an outage. So to answer the other question, how do we prevent the enumeration through the domain? There is an NSEC 3 record, which is just starting to poke its head above the water. It's covered in RFC 5155, and it deals with using hashes to obscure the domain names, but still giving validation on proving that it's not within. So it's an additional step. There's a little bit more work. The way the NSEC 3 records work, they're actually a new type of NSEC record. with a different algorithm ID such that unaware clients end up actually ignoring the record and basically return an unknown status. So until more services start really implementing the NSEC 3 on the verification libraries, you'll actually end up with some weird, hey, things didn't validate correctly, but I'm pretty sure it's there. That would be why. So it just needs a little bit more time to shake out and get some better implementation there. The DLV record type is what's actually held by the DLV vendors for your particular domain. This output would be generated by your signing command, and it's basically what you would hand over to your DLV. It's similar but not quite the same as far as function as a DS record. You'll notice that the data looks identical, but it's a different record type to indicate that a different lookup mechanism is being used to pull that information down. Here are the two big URLs you should probably pay attention to if you're going to jump into this. The first one is clearly the most important. The second one basically has the instructions for setting up the ITAR trust anchors. It's not quite as important, but having some of the DLV in place really gets you a good win. If I'm remembering correctly, I think .gov has recently added themselves to ISC's DLV, so you actually get some verification there of the top-level .gov site. Now the other top-level domains can catch up. Any questions?
Say, any idea on a timeline of when the other top-level domains will catch up to .gov as far as the signing goes?
No. Actually, with the ITAR, you'll end up with a lot of country codes getting listed in there, and the smaller TLDs. The problem is that the big TLDs are big, and it's like turning an oil tanker. It's going to take a lot of effort, a lot of momentum to get things turned, and I mean, flat out, there is additional overhead in serving up DNSSEC. That if you go back and you look at that RRSIG record, it can be up to an order of magnitude larger than an A record. So for sites that are worrying about how many DNS servers they need to put out to handle the load, it's a serious concern because it's just that many more bits going down the pipe. And a lot of the top-level domains, com, net, org, they're pretty big. And going out to them and saying, hi, yeah, we're going to hit you with an order of magnitude more traffic. Have a nice day. It takes a while for them to ramp up to that. Does that answer your question? Yeah. Anyone else?
So this seems like a house of cards from the perspective that if .dot or .com or any of those gets compromised, everybody's compromised. And it seems like I don't know if DNSSEC is the be-all, end-all to this solution. Has there been any talk about like DNS curve from DJB DNS or any of those types of security measures? Have you played with any of that?
No, I actually haven't played with any of the DJB DNS stuff, unfortunately. I haven't been able to get my finger in every pie.
Okay.
If you've got experience with that, I'd love to talk to you offline.
No, but I'm just listening to this going, you know, it's very time-intensive, labor-intensive to do this type of a setup, the key
Not,
setup?
actually, to actually get something like this set up,
Well, to you and I, it's trivial. To DNS administrators, it's going to be...
actually, we're getting down much closer to really quick recipes to getting these things set up. ISC thinks that DNS administrators can get some of the mechanics done in under 10 minutes. With the commands laid out here, you're really limited by how beefy of a CPU you have. It takes a little while for my Cobalt Rack 2 to do any signing. But it's still, even with that system, it still completes pretty quickly. And I could probably have everything reset up within 10 to 15 minutes, even on that ancient and that slow of a machine. Now, when I started all of this, you had to wade through pages of instructions where the instructions themselves started delving into weird discussions about algorithm choice and strength and choosing the right bit length, and a lot of that was largely unnecessary, and that did turn off a lot of people and did give a fairly negative stigma on turning up DNSSEC. The people viewed it as hard as a result. I've talked to multiple people who have attempted and gave up because at that time the instructions were for cryptographers, written by and pretty much for. The instructions are largely for ops people now. Anyone else?
Going once. Going twice.
Thank you.